Okay, that last one wasn't so bad. So let's try example 2. Oh boy, they didn't factor it for us. So when they say find the roots, we're the ones who are going to have to do the finding. So we're still looking for all the x values that will make this fraction, when it's finished, come out 0 or above. This fraction's value has to be greater than or equal to 0. We're looking for the x values that will make that happen. So I guess we're going to factor the numerator and the denominator. I'm going to tackle the numerator first. Now it does have 4 terms. Sometimes we can get away with splitting them down the middle. Sometimes not. Let's see if this works. So between x cubed and 3x squared, there is a common factor of x squared. When we pull that out of the x cubed, there's an x left. When we pull that out of the 3x squared, there's a plus 3 left. We are hoping that we can get an x plus 3 over here. Well, they do have a common factor of negative 9. So if we pull that common factor out, negative 9 out of negative 9x is just x, and negative 9 out of negative 27 is just plus 3. So we do have 2 chunky terms here with a common factor of x plus 3. When we pull the x plus 3 out of the first term, we've got an x squared. We pull the x plus 3 out of the second term, we have a minus 9. It's looking factored, but not fully factored, because this is x plus 3 times, and the x squared minus 9, difference of 2 squares, breaks down to x plus 3 times x minus 3. Now we can make this x plus 3 the quantity squared, or we can leave it as 3 different factors. I'm going to go with the squared. So we now have the numerator all nice and factored. The denominator. Well, it's quadratic. Maybe it'll factor. If necessary, we'll go to the quadratic formula. Then to put the answers on the number line, we'd have to look them up in the calculator. So 1 times 25, b is negative 10. We need 2 numbers that multiply out to 25 and add up to negative 10. That's pretty easy. So this factors to x minus 5 times x minus 5. I'm going to put them as x minus 5 quantity squared. And that's our denominator. So this is the factored form. That's the one we're going to use to test the values in to see what comes out positive, what comes out negative. But this fraction is still going to have to end up being greater than or equal to 0. So the roots, the reason why we factored this, so that we can get our spots on the number line. According to what we did here, if x plus 3 is a factor, then the numerator roots are going to have to be x equals negative 3. And if x minus 3 is a factor, then another numerator root is going to have to be x equals positive 3. This happens to be a double root. That's okay. We're only going to count it once. And then in the denominator, if x minus 5 is a factor, that means x equals 5 is a root. And we know that we are not going to be able to include it in the final answer. So we have 3 roots that we are going to mark off on the number line. And they are just happen to have turned out in order. So we have a negative 3, we have a positive 3, we've got a positive 5, and that's it. So the 3 roots should divide it up into 4 intervals. But before we go to the intervals, because this will make the denominator turn into a 0, we know we can't use that root. So it's going to have an open circle here. We're not allowed to use the 5. Even though it's got the equal to sign up there, we're not allowed to use the 5. How about the 3 and the negative 3? Should we put a closed dot, open dot? Well, we can use them because they don't make the denominator equal 0. And this does say we want to include an answer of 0. So we will put a solid dot on each one of these. They will be part of the answer. This one cannot be. And then we just set up our intervals. So this is from negative 3 on down. Oh, got a little carried away there. Negative infinity is having a little trouble there. Up to negative 3. And I should have included the negative 3. That's supposed to be straight side there. And then negative 3 to positive 3. And we're going to include both of those because they can be part of the answer. And then from positive 3 up to but not including the 5. And then from 5 not included up to infinity, which we're never going to get to. I keep wanting to fix this. So now that we know we're going to have to test a number in here and in here and in here and in here. 4 separate tests. And once again, I'm going to copy the problem down so that I can fit it all on the screen. Now, if you wanted to leave this as x plus 3 times x plus 3, that's fine. Whoops. So, pick a number that's in between negative infinity and negative 3. I'm going to test negative 4. Could have tested negative 10. Could have tested negative pi. But nah, I'm going to test negative 4. So if I put a negative 4 in here, that's going to come out negative. But when we square it, it's going to come out positive. In fact, no matter what we put in here except 0, when we square it, it's going to come out positive. So this parentheses thing, except for negative 3 plus 3, is going to always come out to a positive answer. Negative 4 subtract 3, that's a negative 7, so this is going to be negative. Down on the bottom, inside the parentheses will be negative, but when we square it, every single time here, the denominator is going to come out to be positive. So we have a negative numerator divided by a positive denominator. Overall, that's a negative result. So any number we pick here is going to give us a fraction that's got a negative answer. Then we pick something from negative 3 to 3. And there are gazillions of numbers. I'm going to test 0, because for me that's easy to substitute in. 0 here, this has got to come out positive. If we put a 0 in here, though, that's going to come out negative. If we put a 0 in here, that's going to come out positive. So that looks just like this one. Apparently this is going to come out to a negative overall result. Anything we put in here is going to make the fraction come out negative. We're halfway done. We need to pick a number between 3 and 5. I'm not going to be original here. I'm just going to pick 4. So 4 plus 3 when we square it is positive. 4 minus 3 is positive. And on the bottom, even though the parentheses would be a negative 1, when we square it, it's going to come out positive. So the general result, positive. No matter what number we picked in here, the fraction is going to come out to a positive answer. And then we can pick any number bigger than 5 at all. I'll go test 10. So this would be a positive. We square it, it's still positive. This will be positive. Down the bottom, this is positive. We square it, it's still positive. So the overall result, positive. No matter which one of these infinite possibilities we pick, the fraction is going to come out to a positive answer. So we have our sign chart. And we're going to use that to find which x values make the fraction 0 or more. Well, it's going to be greater than 0 anytime the fraction comes out positive. So that would be these right here. They probably stayed positive because 5 was a double root. And here they probably stayed negative because negative 3 was a double root. Anyway, according to this sign chart that we have, it's going to be greater than 0 in here and in here, but not at that one spot right there. So we could say from negative 3 to 5, union from 5 to infinity. We have to show that the 5 itself is getting left out. And that almost looks like we're done, except that it did have this equal sign. So anything that made the answer come out equal to 0 has also got to be included in the final answer. And this spot right here, that one single dot, even though it was negative on this side and negative on that side, if we put in a negative 3, that will make the fraction come out to be equal to 0. So because interval notation always starts at the lowest end, I got to put it out front here. Now it's a little weird. How are we just going to say one dot? Well, one way they do that is say that the interval goes from negative 3 to negative 3. And that will include just the number x equals negative 3. Any of the numbers in between here, along with any of the numbers from here on out, would all make this original mess of a fraction up here come out to be greater than or equal to 0. Thank you for looking at example 2. And now it's your turn to try a couple of problems, please.